Hello, my dear friends. How are you all? I hope you all are good and fantastic. So, friend, today we are going to discuss very amazing topic, arithmetic progression. Okay, so you are very welcome in our lecture number 1. Okay, friends. So you have to be concentrate. Okay, and you have to be listen very carefully. Okay, so without wasting the time, let's start. Yes. So in this chapter, we will discuss Introduction to Arithmetic Progression, general terms and various formulas in AP, such as some of the n terms of an AP, nth term of an AP, and so on in details and with a lot of examples. Okay, so I hope you will enjoy this lecture. Okay, so yes, Introduction of Arithmetic Progression. So in this, so in this, first of all, we have to see some definitions. Okay, what are the definitions? So okay, so what is sequences? So my dear friends, a sequence is a finite or infinite list of numbers following a specific patterns, following a specific patterns. Okay, let's suppose we have a sequence like this: 2, 3, 4, 5, and so on. Okay, so we have a sequence like this, and this is the sequence which is followed by a following patterns, because this is the increasing order of the numbers. Okay, 2, 3, 4, 5, 6, and so on. Okay, I hope you get this point. What is sequence? So what is sequence? It may be finite or it may be infinite. Means, let's suppose we are taking like this: 2, 4, 6, and 8. Okay, this is a set, this is a sequence, and this is a finite. This is what? This is finite. Okay, and this is what? This is infinite. This is infinite. Okay, so I hope you get this point now. So let's talk about the terms. What is terms? So in the sequence, each numbers, we can call it as a terms. Like, for example, we have 2, 4, 6, 8. Okay, we can call it as first term. Okay, we can call it as second term. This is our third term, and this is my fourth term. Okay, my dear friends, I hope you get this point. So this is a sequence and terms. Okay, so now let's move on. Yes, now we are talking about what? We are talking about series. What is series? Okay, so what is series? So a series is the sum of the elements in the corresponding sequence. In the what? In the corresponding sequence. Okay, for example, we have a sequence like this: 1 plus 2 plus 3 plus 4 plus and 5 plus and so on. So this is the sequence which is followed by a sum pattern, and the summation of this, okay, and the summation of all the terms is called the series. Is called the what? Is called the series. Okay, so we can call it as it is a series of natural number. It is a series of natural number. So each number in a sequence of series also is called a term. We can call it also as a term. We can call it as a term also. Okay, so this is our first term, second term, third term, fourth term. Okay, so let's take another example: 2 plus 5 plus 8 plus 11 is equals to, and so on. So this is again a series. Okay, I hope you get this point. Now let's come on progression. Let's come on progression. Okay, so what is progression? So friends, a progression is a sequence in which the general term can be expressed. General term can be expressed using a mathematical formula. Using what? Using mathematical formula. Okay, my dear friends, I hope you understand it. What is progression? So progression is a sequence wise pattern. It is a sequence which is followed by a pattern in which the general terms can be expressed by using the mathematical formula. Let's suppose we have 1, 2, 3, 4, and so on. This is our progression. This is our what? This is our progression. Okay, this will goes to n, and n is what? N is our natural number. N is our, yes, number of terms. So I hope you understand this. So now let's move on. Yes. Now let's come on arithmetic progression. Our main topic is arithmetic progression. Okay. So what is arithmetic progression? So an arithmetic progression is a progression in which the difference between two consecutive terms is constant. What is? Yes, the difference between two consecutive term is constant. Okay. For example, let's suppose we have a series 2, 5, 8, 11, and 14. Okay, and so on. This is a what? This is a arithmetic progression. Okay, so what is arithmetic progression? It is a progression in which the difference between two consecutive number. Now we have to find the difference between two consecutive number. What is? If we subtract 5 minus 2, we get what? We get 3. If we subtract 8 minus 5, we get again 3. If we subtract 11 minus 8, we get again 3. And again we get what? 3 by subtracting 14 minus 11. Okay, so the difference between two consecutive term is constant. Now here is 3, 3, 3, and 3, which is what? Which is constant. So we can say that this is what? This is an arithmetic progression AP. What is AP? AP is what? AP is arithmetic progression. Arithmetic progression. So my dear friends, I hope you understand this. What is arithmetic progression? What is? Yeah. Okay. So now let's move on. Yes. Now what is common difference? What is common difference? So the difference between two consecutive terms. The difference between what? Two consecutive term in an AP, which is a constant. Okay, is called the common difference. Is called the common difference of an AP in the progression. So for example, we have what? We have a series, we have a sequence 2, 5, 8, 11, 14, and again so on. Now my dear friends, if we subtract it, we get 3. Again we get 3, 3, and 3. Okay, if you observe this, the difference is same every time. So this difference is called the common difference. It's called the what? Common difference, and we can represent it as D, small d. So what is D in this case? The D is 3. Okay, so this is our D. So as it is the difference between any two consecutive terms for any AP, if the common difference is, so there are three conditions. What? Yes, there are three conditions. If the common difference, if the common difference is, first case is, if the D is positive, then the AP, then the AP is what? Then the AP is increasing, means in this case you can see that D is what? 3, which is positive, and the AP is continuously decreasing, 2, 5, 8, 11, 13, and so on. Okay, my dear friends, so I hope you understand this. What is, yes, what is, yeah, if the common difference is positive, then the AP is what? Increasing. Now second case is, if the common difference is negative, then the AP is decreasing. Then the AP is what? Decreasing. Let's take an example. Now let's suppose we have D is -3. Okay, so in that case, the AP is 14, 11, 8, 5, 2. Okay, so in this case, if you observe this, the common difference is negative and the AP goes decrease. AP is decreasing. Okay, if you find it, you can also verify it by subtracting 8 to -7, means 11 minus 14 is -3. Okay, my dear friends, now let's go on. So the third point is that if the D is 0, if D is 0, then the AP, is constant. AP is what? AP is constant. Okay, I hope you get this point. What is? Yes, if the D is 0, then the AP is constant. So there are three conditions. If the D is positive, then our AP is decreasing. Okay, if D is negative, then our AP is decreasing. If D is 0, then the AP is constant. Okay, so I hope you get this point. So now let's move on. Yes. Yes. Now, finite and infinite AP. What is finite and what is infinite AP? So when we talk about finite AP, the AP in which whose numbers are finite, means we have an AP like this: 1, 2, 3, 4, and 5. This is our AP, and this is our what? This is our what? Finite AP. Okay, so this is our finite AP. Finite. Why it is finite AP? Because there are fixed finite numbers. We are, in this AP there are last numbers and first number as well. So we can say this is our finite AP. And if you talk about infinite AP, in this like 2, 4, 6, 8. Okay, 2, 4, 6, 8, 10, 12, and so on. So this is our what? This is our infinite AP. Infinite infinite AP. Okay, why it is infinite AP? Because there is no last terms in this AP. You cannot find any, you cannot see the last term, so you can say that it is what? It is infinite APM. So I hope you understand the difference between finite AP and infinite AP. So now let's move on. Yes, so the general form of an APM. What is the general form of an APM? So my dear friends, let's suppose we have an AP A1, comma A2, comma A3, comma A4 and so on. ठीक है? अरे यार, ये कितनी प्रॉब्लम आ रही है? दो बार इरेज करना पड़ेगा मेरे को, वो कट करना पड़ेगा. Okay, yes. So the general form of an APM. What is the general form of an AP? Let's suppose the general form of an AP is, let we have an AP like this: A1, comma A2, comma A3, comma A4 and so on. Okay, my dear friend. Now in this case, we have, this is first term, second term, third term and fourth term. And in an AP, you can find the other terms with the help of common difference. Let's suppose we have a common difference is D. D is what? D is common difference. Now in this case, we can find it like this. Now we have A1 is equals to A. A2 is what? A2 is A1 plus D. A1 plus D. And what is A1? A1 is A plus D. What is A3? A3 is A2 plus D. Means, what is A2? A2 is A plus D. A plus D plus D. Then A plus 2D. A plus what? A plus 2D. Now we can easily find A4. What is A4? A4 is A3 plus D. And what is A3? A3 is, we have A plus 2D plus D. Now we can say it A plus 3D. So what are these? Yes, A plus D, A plus 2D and A plus 3D. Now we can find any of the term, like if we want A50. What is A50? We can write it as A plus 49D. Means we just have to subtract 50 minus 1 and we get, yeah. So let's suppose we have an AN. We can find A plus n minus 1 into D. So I hope you understand this. What is the general form? Okay. So now again, now let's move on. Yes. So now we have to do some questions from which we can clear all the concepts. Okay. Yeah. So the question number first is, what? In which of the following situations does the list of numbers involved make an arithmetic progression and why? Okay, so first of all, we have to find it will make a AP or not. Okay, so how we can find it? Let's do that. First question is the taxi fare after each kilometer when the fare is 15 kilometer for the first kilometer and rupees 8 for each additional kilometer. Okay, and rupees 8 for each additional kilometer. Okay, yes. So now in this case, what we can do it? We can do like we can write the given condition as we can write the given condition given condition as the taxi fare the taxi fare for 1 kilometer, what is it is 15 rupees. It is what 15. Okay, so taxi fare for what for 2 kilometers, for first 2 kilometers, then we get what 15 plus 8, we get 23. So the taxi fare for 3 kilometer is equals to what 23 plus 8 is equals to, yes, if we add this we get 31 kilometer. Okay, so now if you talk about for taxi fare for 8 kilo, oh sorry, for 4 kilometer, 4 kilometer, then we get 31 plus 8. Okay, 31 plus 8 what 39. So friends, this is our AP, what 15, 23, 31 and 39. Okay, so I hope you get this point. This is our what, this is our AP. Okay my dear friends, so now let's move on. Yes, so now my dear friends, so the next question is the amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. Okay my dear friends, so now my dear friends, we have a cylinder in which air is present. Okay, so let the volume of air in the cylinder. Okay, so volume of air in the cylinder, let's suppose we are taking as a V. Okay my dear friend, so according to question, vacuum pump removes 1/4 of the air remaining in the cylinder at a time. Okay, so my dear friends, according to question, vacuum pump is what, vacuum pump removes 1/4 of the air remaining in the cylinder at a time. So my dear friends, after every stroke, the volume of air, the volume of air removes 1/4 of the present air. So now my dear friends, so now after first stroke, after first stroke, okay, so the air will remain like V minus V upon 4, because 1/4 of V is V upon 4, so this will get 3V upon 4. Okay my dear friend, I hope you get this point. Now after second stroke, so the remaining air is what, remaining air is 3V upon 4. Now we have to subtract 1/4 of this part. Okay, so this will give 3V upon 4 minus 1 upon 4th of 3V upon 4. I hope my dear friend you understand these things. So 3V upon 4 minus 3V upon 16. Okay, so after solving this, we get 16 as a LCM, and if we subtract we get 12V minus 3V, so which is equals to 9 upon 16V. So we can write it as 3 upon 4 whole square V. Okay, I hope you get this point. So now after third stroke, after third stroke, we have what? We have 9v upon 16 minus 1/4 of 9v upon 16. Okay, so this will become 9v upon 16 minus 9v upon 64. Okay, so now my dear friends, 64 is the LCM. Okay, now here is 36v minus 9v. So this will become 27v by 64, which is equals to, we can write it as also 3 upon 4 whole cube v. So the series will become v 3 upon 4v, 3 upon 4 whole square v, 3 upon 4 whole cube v, and so on. And we can write after fourth stroke, after fifth stroke, okay, and so on. So now my dear friends, if you observe this, there is no common difference. Okay, so we can write it as also, we can write here as the above sequence is not an AP. Okay, I hope my dear friend you understand these things. So now let's move on. So the next question is, write first four terms of the AP when the first term A and common difference are given as follows. So friends, we have A means first term and D means common term, common difference. Then we can find very easily first four terms. How? Let's see. So we have A is equals to 10 and D is equals to again 10. So this is our first term. And what is second term? The second term is first term plus D, and we can write it as 10 plus 10. This is what? This is 20. Now what is third term? Third term is A2 plus D. And what is A2? A2 means 20 plus 10. We get 30. And again we can find A4. A3 plus D, and 30 plus 10, which is equals to 40. So they are, my dear friends, first four terms. Okay, I hope you get this point. So now let's move on. Yes, so the second question is, we have A is equals to minus 1.25 and D is equals to again minus 0.25. So in this case we can do, we have to find A2. What is A2? A1 plus D. Okay. Okay. So now here we can find easily. So we have A1 is minus 1.25. Okay. Plus D is minus 0.25, which is equals to minus 1.25 minus 0.25. Okay. So now we get what? We get minus 1.50. This is our A2. And what is A3? So A3 is same, A2 plus D. So minus 1.50 minus 0.25, and we get, yes, minus 1.75. And A4 is, I hope you understand these things, A3 plus D, then minus 1.75 minus 0.25, which is equals to minus 2.0. So my dear friends, so this is the method to find the next four terms. Okay, yeah, so now let's move on. Yes, for the following APs, write the first term and the common difference. Now in this case, we have an AP and we have to find the first term and the common difference. So we can directly say, that the first term is what? First term is 3. Okay, now we have to find the common difference. How we can find? We can find it by the difference of consecutive numbers. Okay, so we have an AP like 3, 1, minus 1 and 3. If we subtract Okay, if we subtract 1 minus 3, then we get minus 2. Okay, what is D? D is A2 minus A1. Or what is A2? This is 1 and A1 is 3. Now in this case, minus 1 and 1. Minus 1 minus 1, we get again minus 2. 3 minus, okay, this is minus 3, okay. This is minus 1. Then 3 minus 3 plus 1 and we get minus 2. So what is the common difference? What is the common difference? Minus 2, minus 2, minus 2, which is the same. Okay. So our D is minus 2. So my dear friends, this is our complete answer. Okay. This is our the answer. So I hope you get this point. So now let's move on. Yes, we have another question, which is where is what is A? A is 1 upon 3. Okay, very easy. Now we have to find D. This is 1 upon 3, 5 upon 3, 9 upon 3, and 13 upon 3. Now we have to find 5 upon 3 minus 1 upon 3. We get 4 upon 3. Now we have to minus 9 upon 3 minus 5 upon 3. Then we get 4 upon 3. Okay. Now in this case, 13 upon 3 minus 9 upon 3. Then we get again 4 upon 3. So in this case, we have what? We have D is equals to, listen, this is common, this is common, and this is common. So we have what? 4 upon 3, which are the result of our question. Okay. So I hope you understand these type of questions, how to deal with these questions. Now let's move on. So now question number 4 is, which of the following are APs? Okay. If they form an AP, find the common difference and write 3 more terms. So first of all, we have to find this is AP or not. So for finding the AP, we have to check the difference between consecutive numbers. Okay. Now let's see that. 2, 4, 8, and 16. If we subtract 4 minus 2, we get 2. If we subtract 8 minus 4, we get 4. And this will get minus 8, which is positive. So now if we see that this is 2, this is 4, and this is 8. So now there is no common difference. So we can say that the given sequence is not AP. Is not AP. Okay, my dear friends, I hope you get this point. So now let's move on. We have minus 1.2, minus 3.2, minus 5.2, and minus 7.2. So we have to find what? First of all, we have to check this is AP or not. So if we subtract this, we get what? Minus 3.2 minus minus plus 1.2, then we get minus 2. In this we get minus 5.2 plus 3.2, we get minus 2. And in this we get minus 7.2 minus minus plus 5.2, then we get minus 2 again. So if we observe it, here is minus 2, here is again minus 2, and here is again minus 2. So this is the same common difference. So now we can say that we have D is equals to minus 2. So common difference is minus 2, which is same. Okay. So now we can say that, yes, we can say that This is an AP. So now we have to write next more 3 terms. Okay. We can write it as A. We have A1, A2, A3, A4, and what is A5? So A5 is A4 plus D, and what is A4? Minus 7.2 minus 2, we get minus 9.2. Now we have to find A6, then A5 plus D means minus 9.2 minus 2, we get minus 11.2. And what is A7? Then A6 plus D, we get minus 11.2 minus 2, and now we get minus what? Minus 13.2. So friends, finally this is our answer. Okay, yes, let's move on. Now we have 3 plus root 2, 3 plus 2 root 2, and 3 plus 3 root 2. So if we subtract it, we get root 2. Okay, now if we subtract it from this, we get again root 2. And again if we subtract it, then we can again root 2. Then we can say that the common difference is same. We can say it is an AP. Now we have to find A5. What is A5? A4 plus D, and 3 plus 3 root 2 plus root 2. We get 3 plus 4 root 2. Okay. Now A6 is 3 plus 5 root 2. A7 is 3 plus again 6 root 2. So these are the answer of this question. Okay, my dear friends, I hope you understand these things. Yes, so now let's move on. Now again we have a question like this. Let's suppose we have 0, minus 4, minus 8, and minus 12. Again we have to find minus 4 minus 0 means minus 4. Minus 8 plus 4, minus 4. Minus 12 plus 8. Now plus 8 means, why plus 8 is here? Because we have to minus like minus 12 minus of minus 8. We get minus 12 minus minus plus 8, we get minus 4. So how we can write here? So common difference is same. We can say D is equals to minus 4. D is equals to what? Minus 4. So this is form an AP. Now we can write is A5 is what? A4 plus D, which is equals to minus 12 minus 4, which will get, yes, minus 16. And A6 is equals to minus 16 minus 4, we get minus 20. And A7 we can write it as minus 20 minus 4, we get minus 24. So this is our answer. So I hope you understood these things. Now again let's move on. Yes, we have a square, a cube, and a4. If you subtract it, we get a square minus a means a bracket a minus 1. We can write it as a cube minus a square, and again we can take a square as a common, and in the bracket a minus 1 is left. Now a4 minus a3. We have to take a3 as a common. We will get a minus 1. So now if we observe it, a minus 1, a square a minus 1, a cube a minus 1, this is not same. So we can say that the above sequence is not an AP. Okay, my dear friends. So now let's move on. So again we have a question like this. So we can solve it as, if we subtract root 6 minus root 3, we can write it as root 2 into root 3, and here is root 3. We can take root 3 as a common, we get root 2 minus 1. Okay, if we subtract root 9 minus root 6, then we can write root 9 is 3 minus, we can write it as under root 2 into under root 3. If we take under root 3, we get under root 3 minus root 2. Now here we can see there is no common difference. So we can say that, my dear friends, the above sequence is not AP. Okay, my dear friend, I hope you get this point. Now the next question is, yes, so this is 12, 52, 72 and 73 and dot dot. So my dear friend, first of all we have to check the common difference. Okay, so now 52 minus 12 we get 40. Okay, and if you subtract 72 minus 52 we get 20. Okay, and 73 minus 72 we get 1. So my dear friends, according to this, there is no common difference. Okay, so we can say that the above sequence is not an AP. Okay, my dear friends, I hope you understand these things. So my dear friends, this is enough for today, and we will meet in the next lecture with the next amazing topic. So thank you very much guys for listening me, and take care and goodbye.